Hi, Matt. Just really keen to get insight from you. Obviously, you spend a lot of time with senior managers, C-board level contacts, and obviously spend time with your other CTOs worldwide. And I know that you've done some analysis and tried to have a look at what the common pitfalls are in taking on AI projects. So I just wondered if you could share some of that with us.
Yeah, sure. So I've done quite a lot of work, written a number of blog articles, an academic piece, in fact, on analysis of the common challenges that we, HPE, have seen our customers fall into as they go on the AI journey. So if I were to sort of paraphrase them, but check out the blog if you want to get into the detail.
Yeah.
I have read it, it's good.
Yeah, lovely, thank you. So the first one is interesting science projects. So if you're people who are working in the lab, they're building AI in the laboratory, it's going to live there, it's going to be created there, and it's going to die there. If an AI project is not tackling a real business problem, then unless you are doing it to experiment with mixing of chemicals, then that's all it's ever going to achieve. Whenever you tackle an AI problem, make sure it links to a real business initiative. The second one is, of the five that I'm going to talk about, data silos. So data silos exist in organizations for very, very valid reasons. It might be related to data security or data privacy. However, there are lots of very bad reasons why data silos have been created in organizations related to data hoarding. You need to break those data silos down to get access to the value that's in your organization. And that data sometimes needs to be lifted out of where it is to get it access from a data science perspective to allow you to construct the models. And you need to do that in a way that is compliant with your organization's governance and security models. Next up, governance. Too much governance, you're killing innovation anyway. Too little governance, and you're creating interesting science projects. So it is about getting the right governance frameworks in place. Lots of organizations already have quite effective governance around their IT or software initiatives. Small enhancements to those can make them very effective when it comes to your AI deployments. Inelastic infrastructure. As we've talked about over the course of the chats that we've been having, making sure that you've got the right GPU-enabled infrastructure using HPE certified hardware is a key enabler to accelerating your AI initiatives. And lastly, build it and they will come. They don't.
So I know that we've talked about it briefly, about the stages of an AI project so far, and it all being about the data. The data is so important. If you haven't got the right data, if you can't start with the right data sets and you can't do the right things with that data, your project's probably not likely to be as successful as you would like it to be. So I think you're going to take us through a bit more detail around these different stages to give us a bit more of an insight into those.
Yes, yeah. I think it's probably best there if I draw them all up. Next up, let's talk about the life cycle associated with artificial intelligence, because it does group into a number of major stages. Now, we need to think about these as being iterative. So it doesn't necessarily mean that they happen in a sequential order, because we might need to iterate through a number of stages in order to identify the correct outcome for that stage. We might need to aggregate stages together to iterate across them, because data science is experimental. So the first thing we need to do is gather the data. We need to find it in all of its corresponding locations and pull it into accessible places. Once we've done that, and don't underestimate the amount of time, effort, and energy that it takes to do this, even when we start thinking about the skills and capabilities that we have, accessing different file formats, data structures, data locations is a challenging thing to achieve. Once we've gathered it, the next thing we need to do is transform it.
because we can't take the original data that we have and put it into our model construction phase. We need to normalize it. We need to find the features within the data set that have the biggest implications on the model. More data into model construction is not necessarily a good thing. It can have both impacts from a storage perspective as well as the computational power that you need in order to train the models. So transformation is a key part of the life cycle. Once you've transformed, you can move into the model construction phase. So you've now got some data, you've refined it, you've transformed it, ready for you to build your models. Now I can go into a model build cycle, and it might be the case that I try multiple models against my transformed data to try and work out which one is the most effective. Once I've zeroed in to the model that I need, I then need to move into the most computationally intensive part of my artificial intelligence lifecycle. Tuning. Tuning of artificial intelligence models, hyperparameter optimization, to use the official technical term, is the most computationally intensive part of the life cycle. As a result, really, you should be fairly clear on the types of models that you're using when you move into this phase. And when you are here, start thinking about using optimized algorithms. So HPE has an academically proven algorithm that is highly efficient at hyperparameter optimization. It is unique at this moment in time. So when it comes to that conversation, it is all about understanding that using very efficient hyperparameter optimization techniques, again, reduces the amount of time that it takes to tune your models, which means you're using less power, less cooling, and as a result, your carbon emissions associated with model construction are significantly lower. The last phase is deployment or serving. So what you want to be able to do is serve up your model for consumption behind an API, as an example. There are a number of serving or deployment techniques that you can employ in the artificial intelligence space. You are not there, you are not done at this point, because if your model starts to degrade in performance, it drifts, you need to be aware of that. That means that you need tools specific for AI, even at this stage, because you are now monitoring to make sure that your AI is performing efficiently in production. All of these stages are automatable, and that is done using a process called pipelines. So your pipelines are the means by which, once you've gathered your data, you transform it, you move into model construction, tune and deploy in an automated fashion. You can include checkpointing in there from making sure that before you deploy into production, you've validated that your model is performing correctly. Using tools to perform all of this for you is critical when it comes to successfully deploying your AI workloads. Of course, all of this sits on top of storage and compute. So you need the right GPU accelerated compute using HPE certified Apollo 6500 Gen 10 Pluses with NVIDIA GPUs to run each one of these phases, with the most intensive being model construction and model tuning. And you can also use NVIDIA technology in the deployment phases or other open source componentry like Kserve. Again, this needs to live on a suitable storage platforms for your AI requirements. Again, you can get suitable storage technologies from HPE to meet your specific AI demands. For example, if you're running complex image processing or video processing, you'll need higher throughput storage capabilities. You also need to think about securing your data and deduplicating it. It's very easy in the artificial intelligence space to duplicate data to store multiple copies. And that's something that you need to bring in technology, because it reduces your overall storage footprint and thus means that you are not only saving money, but you're reducing time because you're doing less decanting, as well as using less power and cooling, and thus reducing your overall carbon footprint. So this is at an abstract level, the AI life cycle that your customers or you will be going through in terms of gathering the data, transforming it, modeling it, tuning it or optimizing it with hyperparameter optimization, and then deploying it, all of which lives on top of data pipelines underpinned by comprehensive compute, storage and integrated networking to make sure that you are moving your workloads around most effectively.